All right, let's get started. We'll begin today with an announcement from a student group.
Hi, I'm Keaton. I'm with the Women in Computing here at the U, and we just wanted to announce an event next week. It'll be on Wednesday, February 13th from 2 to 3 p.m. in the room number Web, or in this building in 3780. And we're having an imposter workshop. We'll have a Google engineer who's going to come and talk to us about imposter syndrome, which is basically when you feel like you're the only one that doesn't understand something, or somehow you faked all of your classes and you don't belong. And it's a feeling that everyone goes through, men and women, so obviously everyone's invited. We will have refreshments afterward, and we would love to see you there.
Thank you. Okay, so this is week 5. After this one, the semester is 1/3 over. PS4 will be due at the end of the week, and as you know, PS4 involves making modifications to PS2 and PS3, including correcting any mistakes it may contain. Are there any questions or problems about anything? Okay, so I want to tell you about a bug, an interesting bug I discovered. So I heard from a student that they failed the 5 last stress tests for PS3. But when they changed from using sorted sets to using hash sets in their representation, so they had a dictionary that mapped strings to sorted sets, they changed that to hash sets. That's the only change they made. They passed all the tests. So they were wondering how that could be, that using a sorted, it wasn't that it was timing out or anything, it was too slow. It failed on sorted sets, it passed on hash sets. And I saw that note, and I was thinking about it, and then they may have deleted it or something, because I didn't see the note again. And so I just sort of ignored it. So I violated Judy's law. I just pretended like I'd never seen it, because I just couldn't explain it. It didn't seem possible. And then someone else posted exactly the same problem. So I proceeded to try to figure out what the problem was. So if you had that problem to figure out, how would you do that? So what I had was a student submission and my test cases. How do you narrow down and figure out what the problem is?
Look at the student's code?
Well, yeah, I could study the student's code. Good, yeah.
Try to replicate the error so that you can understand exactly what went wrong.
Okay, certainly I replicate the error, and so I find if I ran, I think it was stress test 15, it would fail it. Okay, and stress.
Why would it fail it?
Well, that's the question. How do you figure it out?
What error?
Oh, it would fail an assertion.
Throwing on.
It had a loop that made some assertions about dependencies existing. So a dependency didn't exist when it should.
Follow the stack.
Or vice versa. Stack trace, well, it wasn't throwing an exception. Well, I guess it was throwing an exception when it failed the assertion, but. Yeah.
Could you put a breakpoint and just kind of check how things were getting added as dependencies?
Yeah, I mean, so there's classical debugging techniques, and it just seemed kind of hard to do that. You know, I didn't want to work that hard. I was tired. What can you do to simplify things, to simplify the problem of doing that job? Figuring out what.
Change your test, you know, and then you pass.
Okay. So one thing I try to do is to make everything simpler. So the test had a whole bunch of things. It would add a bunch of dependencies, and then it would replace some and remove some. And so I started commenting out parts of the test. And it kept failing, it kept failing, it kept failing. And finally I had it narrowed down to, it adds a bunch of dependencies and then sees whether the right number of dependencies exist for each I think I got down to dependents, not even dependees, and it was still failing.
Sorted sets store duplicates.
Sorted sets don't store duplicates. And so then there was a constant in there, 800, that it was using to determine how many dependencies to add. So I started reducing it, and I found out if I cut it to 400, it passed the test. 600, it passed the test. 700, it failed. And I got it down to where it failed when the number was 670, and it passed when it was 669. And it was off by 1. It was missing, like it was supposed to, when something was supposed to have, say, 500 dependents, it only would have 500 or one less, whatever I said. If it was supposed to have 500, it would only have 499. Okay? And I still didn't feel like looking at the student's code, because it struck me that this should not be happening, right? Why should it matter if it's a sorted set or a hash set? And so I decided to see, okay, I will just forget about dependencies. I took the strings, so that I was generating 670 different strings to use these dependencies. I just created a sorted set and added strings to it. So I got rid of the student's code. My test was simply to take a sorted set, add the 670 strings to it, and see how many strings the set contained. And I would do that, and it would contain one fewer than it was supposed to. If I put 670 in, it only contains 669. So my program at this point was very simple, just a loop. Generating these strings, throwing them in the set, and then seeing if the right number were in the set. And if I used a sorted set, it lost one of the elements. If I put one of the, if I used a hash set, it didn't lose one of the elements. What's going on?
Oh,
Yeah?
is it because the sorted says index?
No, the sorted set's not indexed. That's not it. I was convinced, this is right before I went home yesterday, I was convinced I'd found a bug in .NET. But it turned out not to be a bug. So here's what I found out. The strings I was generating, the first string was the letter A, and then B, and then C, and then D, and so on through Unicode. So I just, every string was a one-character string, and I got the character by starting with A and indexing by 1. Just doing consecutive Unicode characters. And it turned out that if you use the same comparison operation that sorted set uses, it compares two strings to find out if they're equal, less than, or greater than, because it has to do the sorting. If the 669th character in that sequence and the 670th character in that sequence, which are different Unicodes, were treated as identical strings. Okay? Each string consisted of, it's like a string consisting of an A and a string consisting of a B were being treated as identical, except it wasn't A and B. It was two different Unicode characters. If that's all the string contained, they were treated as identical by the sorted set. But the hash set was treating them as different. That still sounds like a bug, doesn't it? So what I discovered is, when you use .NET, you can specify a culture. And the default culture, at least on my installation, is US English. So culture is going to govern things like when you print out a time, what's the default form of the time? Is it a 24-hour clock, a 12-hour clock? Probably currency symbols, standardized phone numbers, I don't know what. But another thing that is customized by the current culture is string comparisons. Because the way that strings are sorted differs depending on, are you in the U.S. or are you in France? You can have different conventions on how things are sorted. And I read, for example, that accented E, an acute E or a grave E, are basically just treated as E's when you're sorting in the U.S., but they sort differently in France, for example. It just turns out that those two Unicode characters are considered the same. They're different codes, but they stand for the same thing in U.S. English culture. But when I changed the culture to sort of a default, I forget what they call it, I could change to a different culture, and then the test, it would pass all the tests. But what really strikes me as weird is that the hash set was using a different way of, you would think it would be using the same way of comparing strings. It would have a compatible way of comparing strings. So it was really bizarre. So it had a logical explanation. But it took me hours to find, to drill down, because I just thought something was broken. Yeah.
Doesn't a hash set like hash the input and that's how it stores it?
Yeah. A hash set has to compute a hash code,
Yeah. Oh, I see what you're saying.
right? And it has to compare strings with equals. So there are three operations that come with the culture for strings. There's the compare operation, the equals operation, and the hash code, all defined by the culture. Yet the hash set wasn't using the same operations as wasn't using compatible operations with this preset. Yeah.
When you finally found the answer, did you just check the hash codes of those two different?
Oh, I checked the hash code, and they hash to different things, and they're treated as different. So I created a little program that can demonstrate. You take these two strings, and you compare them using the operations that are being used by the sorted set, and it says they're the same. You compare them using the operations used by the hash set, it says they're different. So that, you could argue that's a bug, that they at least ought to be compatible. Do the same thing, but they don't. Yeah.
I have a bug that's more confusing than that one. That's really similar.
Mm-hmm.
In stress test 1 works fine, and if I take the code of the second and third one and put it where the first one is, it runs, but in their own spot they don't.
Okay, I won't try to figure that out, but I'd like to look at it. So I mentioned that just because it was a real life exercise in debugging for me. That I spent a couple hours at work and another hour at home trying to figure this out. And what really paid off was gradually, rather than try to debug the massive code originally, just trying to see how simple I could make the test and still have it fail. And that's when I was led to the solution. I couldn't believe what I was seeing, and I Googled about it, and lo and behold, it was a thing. So I changed the test case. I basically just reduced the number from 800 to 600 or 650 or something. Some of your stuff, none of the grades have been released, but some of the assignments were graded before I changed the test cases. So if you find that if you use a sorted set and you fail those last 5 stress tests because of it, let us know, we can fix that. Okay. On to other stuff. Okay, so some of these stress tests I create have timeouts. So that, if your program takes too long, you fail the test. The timeouts are pretty generous. And but it becomes an issue when we get into PS5 and PS6 when you're implementing a spreadsheet, where it's possible to have implementations that work in certain situations but are way too slow, like hours too slow, literally, for certain kinds of inputs. So what should you do if your program is too slow? Or what should you do if your program runs out of memory? How do you make your program faster? How do you make your program use less memory? Because you're running into this sort of thing.
Change the data structure.
Yeah.
Just rethink your implementation.
Okay, he said rethink your implementation. Someone said use a new data structure. Yeah?
Find the bottleneck.
Find the bottleneck. Yeah. Yeah?
Maybe reusing variables if they're no longer needed.
Okay, maybe you're using variables that are no longer needed. So let's look. I think some of the suggestions have already been said here. So first of all, there's code tuning, making small scale changes to correct code with the hopes of running faster or smaller. So we'll look at all these in more detail in a second. Maybe you just need a better algorithm. Maybe you're using selection sort. Switch to merge sort or quick sort. Maybe you're using a bad data structure. Maybe you're using a list when you should be using a set. It can make a big difference. Maybe your high-level design is wrong, and if you split things up a different way, your program would work better. Another way to improve performance is use multi-threading. We'll start talking about that next time. But you have a multi-core computer, so use more of the cores. Do things at the same time. Pay attention to external interactions such as file I/O. Because trying to reading data from a file is slow. In 4150, there's a weekly assignment that students have to do, and they get a programming problem on a system called Caddis, which is just an automatic judge of correctness for the program. And they write their program and they submit it, and they're told it either passed all the tests or it didn't pass all the tests. But as a side effect, it keeps a leaderboard. It shows the fastest solution in each language that have been submitted over time, over multiple semesters. And some of the students that have too much time on their hands, they get the program to pass, and then they spend many more hours trying to get faster than the person ahead of them on the leaderboard. And often, the difference in speed has nothing to do with the algorithm, using the absolutely best algorithm. But they can still make a massive improvement. And can you figure out why? How could they make a massive improvement if they're using the right algorithm? Has to do with this last point. Yeah?
Using buffered reader instead of like scanners.
Okay, he said using buffered reader instead of scanner. So that's right. Some of these problems have massive amounts of input. And for some of the problems, the algorithm is really fast, and the program is spending all of its time, almost all of its time, just reading the input. In Java, scanners are notoriously slow, and you can speed it up quite a bit just by using a buffered reader instead of a scanner, as he said. But I've had students that have gone so far as they're using C, with scanf and printf, which are low-level ways of reading formatted input, and they switch from using scanf to using byte level. They read bytes, blocks of bytes, and do their own conversion from bytes to integers. And they've got to read integers. So they're kind of maniacs about it. But that way they can squeeze, a 100th of a second off the runtime and move up on the leaderboard. So that has to do with file I/O. Those external interactions can be pretty expensive. Sometimes maybe all you need is a better compiler, or change your settings so it produces faster code, or buy a faster computer. People laugh, but let's suppose that you've put a lot of sweat and toil into a program and it's not fast enough for its intended application. If you can go spend a few hundred, $500 and get a computer that's twice as fast, suddenly your program's twice as fast. That might be the thing to do. It might be cheaper than continuing to code. So this used to be a thing, code tuning. So you might say, okay, I've got to do a plus b divided by 2. What would be a faster way to do that? You've got to average two numbers, yeah?
A plus b times 0.5.
Well, you said a plus b times 0.5, but that would produce a floating point number result. And let's say a and b's are ints.
2x equals a plus b.
No, we've got to store the quotient in x. Yeah?
Can we do a bit shift?
You do a bit shift. So just like dividing by 10 in decimal, you throw away the last decimal point. So the machines do a bit shift in one instruction. So you shift it by 1 bit, you shift away the low order bit, and you've divided by 2. And that's faster than doing integer division. Or, suppose you're doing that in your program. What would be a faster way to do that?
Is it just a plus b squared?
Well, the idea would be that looks like you compute a plus b, and then you recompute a plus b, and then you multiply them. Obviously, you want to compute a plus b once, and then multiply it by itself. So it's attractive, it's tempting to go through your program and make little low-level changes like this. The problem is, if you do that, if you take it to an extreme, your code becomes hard to understand. But the other thing is, compilers already do that for you. So this used to be a thing that people worried about. Low-level tunes to their code, but now any decent compiler will turn that division into a bit shift. Will turn that multiplication into its efficient form. So you should, when it comes to this level of optimization, leave it to the compiler. Write your code to be clear and let the compiler produce the code. But do keep in mind that you can do a debug build or a release build. A release build is going to be faster. But you've also got to worry, you're essentially compiling, if you do all your testing with a debug build and finally get your program right and then ship the release build, you're basically shipping a program you haven't tested. So at least after you build it for release, run the test again on the release build. Okay? So better algorithms can make a huge difference. So just tell me, how much faster is binary search than linear search on the million element array? Well, you say log n. I want a number. How many times faster?
Log of a million.
Oh, I don't know what. Log of a million. Okay, well, what is log of a million?
Is it about 20?
Yeah. Log of a million is 20, roughly. So it's going to take 20 probes to do a binary search, or versus a million for a linear search. So it's a million divided by 20, which is 50,000. So it's roughly 50,000 times faster to do a binary search than a linear search. Right? That's big. If you go up to a billion element array, then it's what? A billion divided by 30. So algorithms make a difference. You study them for a reason. You don't have to, you can learn all about algorithms. That doesn't mean you have to go out and implement the algorithms every time you want to use it. You just know, you know to go out and find a certain algorithm or use a certain data structure. On the other hand, is it worth it to sort an array if you're only going to search it once? Suppose you need to find something in this million element array. Is it worth it to sort it so you can do a binary search? Or should you just do a linear search? Will it pay off to sort it? Is it worth the sort in order to get the fast search? Yeah, it's not going to be worth it because this fast search just looks at every element once, and sorting it's going to do that and more. So, you have to think like that. Better data structures can make a huge difference. Array lists can use less memory than linked lists. Depends. But depends what you're going to do with it. It's really slow to insert into the middle of an array list, fast to insert in the middle of a linked list. And so there are always trade-offs. So you have to learn, use what you've learned about algorithms and data structures to figure out the best way to do things. So in PS3, if you had your choice between a sorted set, which uses red-black trees, or a hash set, which uses a hash table, which should you pick? Ignoring this bug I discovered, this thing I discovered, which is faster. Yeah, hash tables are faster. You'd only use the tree if you needed to have things in sorted order for some reason. Now, we'll delve into this next time, like I told you. But nowadays, the only way to benefit from hardware improvement is multi-threading. So in the old days, the rule of thumb was every 18 months, your computer got twice as fast. So your programs would get faster and faster as the computers got better and better. But nowadays, it's not so much that the computer is getting faster, it's that as time goes on, there are more cores. So the individual cores, the individual processing elements in the computer really aren't getting faster. It's just there are more of them. So if you write a program that only uses one of the cores in your computer, it's not going to get faster over time. The only way to make it faster is to allow it to exploit all the cores on the hardware. This is what I just said. So we'll look at multi-threading. File systems, as I already said, can cause a big performance hit. And I won't dwell on it. We'll talk about that next time. But you can use multi-threading for that as well. So if you need to improve your program, you need to make sure you have a problem, first of all. Maybe a program's fast enough. So don't start making it better unless you really need to make it better. Before you do anything, make sure that you have some good tests so that as you make your changes to make your program faster, you don't break it. You've got some way of just detecting if you've broken it. Have any of you ever taken a perfectly working program and optimized it until it didn't work anymore? Anyone want to admit to that? Yes, I have done that. You know, I take a program and I say, I'm going to make it better, and then I work on it for a while and it doesn't work anymore. So make sure that you've got some way of judging as you make changes that it's really still working. And make sure that you commit often as you're doing this so that if you do screw something up, you can back up easily. And quit when it's good enough. And this is a common saying, the perfect is the enemy of the good. But, you know, you can spend forever making it perfect. And might as well stop when it's good enough. Now, this is the topic of the lab tomorrow, profiling. Before you start trying to make your program perform better, someone mentioned at the beginning of class, you need to find out where the bottleneck is. Where is the problem? If the part of the program you're making faster is hardly ever executed and only contributes, you know, 0.5% to the runtime, it's not gonna pay off to make that part faster. You want to make the part that's run a lot faster. And so that's what profilers are for. So profiler is a tool that'll tell you where a program is spending its time or where it's consuming its memory. So it'll tell you stuff like the number of times a method is called. So essentially you'd have some test cases, let's say, and you run the test cases with the profiler on. It'll tell you the number of times a method is called, the percentage of the time it's spent in the method. It can show you how much of the heap was used at any point in time. So you use profilers to find what are called hot spots in the program. You use a profiler to look and find the method that's being executed 75% of the time. And they actually observe a running program. So there are two types, and both support in Visual Studio. You can experiment with them tomorrow. There's sampling, which essentially your program runs, and every now and then the profiler wakes up and notices where the program is executed. It's executing at that instant in time and remembers it. So it's statistical. Another thing is instrumentation, where your code before it's run is actually modified to include profiling code. And both have their uses. And you can play with them. And when people come to me and ask, how can I speed up my program? The answer first is going to be, find out what's slow about it. Profile it and find out where it's spending its time. Okay. So that is profiling and performance enhancement. Any other questions I could answer about that? Okay, so here's the next topic. At some point, I'm not sure if it's PS5 or PS6, both PS5 and PS6 should be building the actual spreadsheet class. And at one point, what I'm going to have you do is add a method that will take your spreadsheet and save it to a file. And then you'll add a constructor that'll take a file and read a spreadsheet from the file and create a spreadsheet object. Now, what is it that you'll be saving to a file? What do you think the representation of your spreadsheet will look like?
JSON or XML?
What's that?
XML or JSON?
Well, I mean when your program is running,
Object.
what will your instance variables be for your spreadsheet? What kind of objects will you be using, you think? Yeah?
Your dependency graph.
You'll have a dependency graph object that'll keep track of the relation, the interrelationship of cells. What else do you think you'll have in your spreadsheet? Yep, a whole bunch of different formula objects. So everywhere there's a formula in the spreadsheet, there's going to be a formula object. So somehow, and there'll be other things. You'll probably have a hash map that maps from cell names to their contents. Something like that. So you have a whole bunch of objects, and somehow you've got to save that to a file. So you've got to convert all those objects into some form you can write to a file, so that you can then turn around and read it out later. And there are lots of strategies for that. So what if I adopted the following strategy? I'll say, make up your own format. Okay, you figure out how you want to save and how you want to read, and just make sure that anything you save can be read. Would that be what would be the problem with that approach, at least from my point of view.
You can't open it, or you can only open it with our code.
Right, basically, the bottom line is I want to test all your code with the same test cases. I'd like to create some spreadsheets for you to read and see if you can read them. But if everyone is using a different format, that doesn't work for me. So we have to agree on a standard format. And a common technique that's used to save structured data, hierarchical data, is XML. So that's what we're going to talk about next. And the reason we're talking about it is it's going to become important when you do that aspect of the spreadsheet. You need to save the state of your spreadsheet to a file. So XML stands for Extensible Markup Language. And the idea behind it was to provide a language-independent way to represent hierarchical data. C# provides convenient ways to read and write XML files, so that all makes it so this is a reasonable way to represent the state of the spreadsheet. So here is a typical XML file. So if you just squint at it, what does that look like?
You got your headers.
HTML. So HTML is roughly a form of XML. So let's see what we've got. You have tags. So you see these are closing tags, the one with the slash, just like in HTML. And there's a corresponding open tag up there. So we open the states, we close the states. So this file is intended to represent information about states and their capitals. And so inside the states tag, we have a whole bunch of state tags. And each state tag, let me get a pointer here. So each state tag, let's see, this state tag has an attribute called capital, whose value is the capital of the state. And then it has a nested tag, which gets the name of the state. So this says, we got a state whose capital is Salt Lake City, its name is Utah. Here's a state, here's another state. So that's the structure of the file. That's how it's all kept. Now, when I created this file, did I go to some central repository of ways to use XML and look up the proper approved format for representing states and their capitals? Does that sound like something I would have done? No, there is no central clearinghouse like that. So how did I know to represent states and capitals this way?
Based on your implementation.
You did it?
I just made it up. Okay? Now, if you're writing XML, if you're writing HTML because you want it displayed by a browser, you can't say, oh, I'm just going to write it this way. You have to write it in some way the browser is expecting to make sense of. I just made up this format. But that just means that any program I write now to read or write these files is going to have to be aware of the format. They're going to have to agree. So what we'll do for spreadsheet is I'll make up some format for spreadsheet, and you all use it. Okay? So what you're seeing up there are opening tags, closing tags, nested tags, attributes. Okay, I want to switch over to coding, to look at code right now. Okay, so this is a xml.cs, an example file. And I'm looking at exactly the wrong file. Sorry about that. Okay, so this is called states1.xml. So this is just an XML file that I put into my program. I'm going to do Control-KD on it to get it to indent properly. That's just the file that we looked at. No, that's not the file we looked at. What's different about this XML here? Yeah?
Instead of having the capital as an attribute to the state, it's a nested element.
Okay. So in this one I decided I would have a state element that would contain two sub-elements. Name and capital. Name and instead of having the capital be an attribute. So there's nothing wrong with that. It's just, whatever way we choose we need to be consistent. Here's states2.xml. So again, Control-K, it's just how you do when you indent your program, Control-K, Control-D. What about this version? Is that the same as the one I showed you? No, here it's purely attributes. So the state tag has two attributes, name and capital. So it's not like there's one right way to do things. You just got to pick a way and agree to use it. Now, what things might you want your program to do with XML files? Yeah,
Read it?
okay. You might want to be able to write a program which reads the XML file. Yes?
Create objects based on like common attributes.
Okay, and as you're reading from the XML file, you would like it, as you read the XML file, like suppose you want to read this into a program and create an array list of state objects. So for every state that you see, you create an object, and you initialize the name and the capital field. And for each state that you read, you put it into an array list. So you'd like to be able to write a program to do that. And so the classes that are provided by C# and other languages to read XML files make that convenient. As you're reading the file, you can run code to create the data you want to use internally. So the problem will be, given a file like that, as you read the file, produce some internal data structure that your program can make convenient use of, because you don't want to write your program to always work in that format. And then the other thing you'll do is, once you have it in that format and you want to save it out, you need a convenient way to traverse the data structure and spit out XML for it. So that's what we need to see how to do, is how to go both ways, how to read and how to write. And there's one other thing you would like to do. Okay? Microsoft Word, for example, uses XML to represent its Word documents. What would happen if you opened up a Word document in Notepad and corrupted the XML? Like deleted a closing angle bracket, or deleted a closing quote mark, or changed the name of an attribute. What would happen when you try to read it with Word? What would you want Word to do if it read in a corrupted Word file?
Open up the code like an open.
Well, yeah.
I would say possibly just delete that one line that had the mistake.
Okay, he's suggesting that try to repair it. But I don't think that's usually a very common option. What's more likely it would happen if you try to read it?
Exception.
Yeah?
Throw an exception?
Well, yeah, an exception would be thrown somewhere, but the end user doesn't want to see an exception. What's the end user? Yeah, I want to see an error message saying this file is corrupted, I can't read it. So as you're reading an XML file, you also like to be able to make sure that it's not some, that it really is the proper XML file and not some corrupted or non-XML file at all. So that's the third thing you need to figure out how to do, is how to read and report when there's a problem. So let's take a quick break, and then we'll start looking at how to manipulate these things in programs. Again. All right, so here's a code example. What I've got here is, I just made an array of however many states that is, 7 states, and then an array that has the corresponding capitals of those 7 states. So what I've got here is code that can write the 2 files. I showed you example 1 and example 2 are those 2 XML files I showed you. So write example 1 is how that file was created in the first place. Write example 2 creates the second one. And then I have code that will read back in example 1 and example 2. And I'll comment out example 3 now. So let's see how to read and write XML files. So here's write example. So there's a class called XML Writer in C#, and it has we use XML Writer, a static method create. We give it a reference to the XML file, and it opens it for reading, or for writing rather. Okay? I don't know if I've mentioned this before or not. What's going on here? Why does it say using there? Sounds like I didn't talk about it before.
Import a specific kind of interface?
Nothing to do with it. It's a completely different use of the word than using at the top. Yeah.
Isn't it like a temporary import?
No, it has nothing to do with importing. Yeah?
I guess it just like opens the file, and then at the end of that using, closes that file.
Right. This just opens the file with the added advantage that as soon as control leaves that block for any reason, the method returns from inside the block, it exits the block, it throws an exception. The file is closed automatically. And there's a similar thing in Java. It's called try with resources in Java. And oddly, Java uses try uses the term try for 2 different meanings, and C# uses using with 2 different meanings. So anyway, that's the way to open a file is to use a using block. Okay, so you'll see there are methods in the writer that correspond to tags. So first thing we do is we start the document, and when we're done, we call end document. So these things have to come in pairs. Then we start an element called states. And then we have a loop, and when it's all done, we end that element. And inside the loop, we go through the 2 arrays. We write out an element called state. I can't remember exactly how this one was formatted, but we put the 2 nested elements inside, and then we write the end element. So it's very straightforward code. Let's, I got to remind myself what states 1 looks like. Okay, so it created these 2, essentially, each time through the loop creates one of those guys right there. That's the wrong file. What's the difference, you think, between write start element and write element string? Notice there is no end write element string. So what's the difference between the way the state tag is written and the way the name and capital tags are written? Yeah?
The write element string will always close itself. You can't nest anything in it.
Okay. So we use this because we're not intending to nest tags inside of this one. It just contains the name of the state and nothing else, whereas we are nesting tags inside a state. All right, so pretty self-explanatory. There's the second one. Starts and ends the same way. And as it goes through, it creates a start element. It starts an element called state. Then it writes out 2 attributes to that element, and then it ends the element. So, this isn't groundbreaking code, but the most important thing is to remember where you saw it, so that when it comes time to do PS, I think it's 6 it's in, I'm not sure, you remember to come back and look here to see how to use this. Okay? We'll look at write example 3 later. So here's code to read example 1. And there are a couple of different ways to read XML. This is the simplest, so we'll just look at it. So we say, all your readers are going to start like this. While there's something to read, and you didn't have that if reader.is start element. And then basically you're switching on tags. So the whole program consists of a loop that has, that's the whole thing. That's the part you have to change. It says what to do when it sees each tag. So what do we do when we see a states tag? We're doing nothing. Okay? What are we doing when we see a state tag? We are writing out a blank line. What are we doing when we see a name tag? We're writing state names equal. Then we are doing a read operation and printing out the value that was just read. Okay, so it's reading the thing that was nested inside the name tag. And then when we hit case capital, we print out the state capital. So what's going to happen when we run this program? And it reads that first XML file. What does this program do?
Just gonna print out state names, capital name.
Yeah, so I'll run it here. And it just consumes that XML file and prints out information. So as it's reading it, it's basically going through that loop. Each tag shows up in the case statement, and it just uses the right call to extract the information from the reader, and it converts it into that form. Okay? So that is that one. Okay, here's an example of how you read the second time. So in the second time, there are only 2 tags. States, which play no role in what we print out, and state. And every time we see a state, we print out a blank line, we ask the reader to give us the value of that attribute of the current tag, and similarly for capital, we print it out. So the same sort of stuff gets printed out. The program looks different because the format's different. Okay, so this pretty much shows you what you'll need to know to read and write your spreadsheet, with one exception, which is example 3. I'll get to that in a second. So any questions I can answer about it? I mean, it's not intrinsically interesting code, and it's not important right now, but will be in a couple weeks. Yeah?
When you want to use an attribute versus like a nested.
Okay, right. So I've shown you 3 different ways of formatting the same information. I don't have any advice for you, which, I think it's just a matter of taste. Well, now, suppose we had, gotten switched back. Suppose we had that, and what we wanted to produce was an HTML page. Formatted, an HTML table that had this information. How would we do that? Yeah.
XSLT or velocity?
Okay, so we said XSLT or velocity. How could we do that just with the C# that I just showed you? So this program here, could we modify this to output HTML instead of this plain text that it's printing? Now that's the right. Let's do the read. So as it reads, it's outputting some stuff. Could we change this to output an HTML table? Yeah?
You just have to change all the tag names. Like the states is going to be table.
Right, so whenever we saw a states tag, we would output table. And when we saw a state tag, we would output a new row. And in that row, we put elements. So we could change this to spit out stuff in HTML. But as he suggested, there's another technique you can use. So this is an XSLT file. I call it XSalt. I'm not sure if that's standard or not. Essentially, this is a program here. So I'm not expecting you to learn or be any good at all or even be able to read. I just want you to know this is possible. So this is a program which consumes a document written in the form of that first example and produces an HTML table as a result. So let's just stare at it and see what's going on. So this is saying, if you see states, you output HTML body, a states header, you start a table, you set the color, you put a heading, you end a row. So that's what, when you see the states tag, you do that. And then it's saying, every time you see a state tag, output a TR, a TD, plug in the name of the state, close the table element, open table elements, throw in a capital, close, and then it just it closes on the way out. So basically, this is not a declarative program in the sense you're used to. It's just tying what should be output to the structure of the original input. It defines a conversion from a particular form of XML to an HTML document. So, like I said, I don't expect you to become experts. I just want you to know that it's a template that'll do a conversion for you. If you know how to write these, you don't have to write code in C# to do a conversion. You can just define the conversion that way. And then, so I've got this thing open. I can go to XML. I can say start XSLT debugging. No, I don't want to start that. I want to start, I'll do it with debugging. Then it's got to pick the file to translate, and I've got to choose the style sheet, so I'll do that. And it normally would prompt me for the XML file to run it on, but I already did this in my office, so it already knows. And so that's the output it produced. It runs the translation on the XML file and produces an HTML file as a result. Some of the information you see on the web is created this way. So that what your browser downloads is an XML file and an XSalt file. And it does the transformation in the browser and displays the resulting HTML. And you don't have to transform. You can define the transformations in different ways. It doesn't have to be to HTML. It's just declarative programming language. There's ones with loops and conditionals and the things you're used to. This is non-declarative. You just say, when you see this pattern, produce this pattern. Let me show you another one. Okay, here's another transformation. And it's basically saying, the guts of it's right here. Each time you see a state tag, you output the beginnings of a row. In it, you stick the value of the name tag. Another place, you output the capital. Then you close off the row. And then when you're all done with all the state tags, you output a closing table and a closing body. So I'll do the transformation exactly the same way. Now, final thing I want to show you about XML, I'll go back in here. I'll tell you what we've shown you. Okay, that's what we looked at in Visual Studio. It's just a file snippet that says what kind of output produce. There's the resulting output snippet. Finally, there's something called XSD for schema definition. So basically, an XSD file is a way to describe the syntax of an XML file. So what I will do is give to you an XSD file. I'll describe the format I want you to use of the XML file for the spreadsheet project. But I'll also give you an XSD file which describes it formally. And you can create your own XSD files if you want to. Basically, you just create an example XML file, and Visual Studio will synthesize an XSD description of it for you that you can then edit if you wish. So how do you suppose, well, I'll just show you this. This is an example of an XSD file. Look at it and tell me, what is it saying? had to guess, what restriction is that putting on the XML file?
Makes sure that the capitals are all stored as strings. And the
Okay,
capitals,
the names and the capitals are stored as strings.
and they have to be there.
Okay, the capital has to be there. It looks like the name of the state's optional. Yeah?
Looks like it can be an unlimited amount of, like, states.
Okay, so it's saying that inside of a states tag, you can have an unlimited number of state tags. Furthermore, it's saying the only two tags it says it allows are states and state. Yeah?
There can be multiple capitals in a state.
I don't think it says there can be multiple capitals in a state. If you look at this, starting right here, it matches.
I think sequence means that it's going to happen over and over again.
Yeah. So the sequence means that you're going to have state tags occur over and over again. But inside a state, there's only one name and one capital. So, you know, you'd have to become an expert in writing these things. It would take a while. But like I said, you can get Visual Studio to generate. That's how I created the one I'm going to give you. Is I just created an example spreadsheet file using the format I had in mind, and then got Visual Studio to create something that described it for me. And then I looked at it. Maybe I changed a few things.
So the schema, it says it's language independent. Like, so does that mean like from language to language, it has each language has a different way of defining XSD files? Or?
Well, it's language independent in that if you wanted to use this XSD file in Java or C# or Python, you'd use the same XSD file.
Oh.
What would differ would be how you read and write from the actual Java or Python.
Like this, right?
But this is the same. Okay. So what's left to show you is, and again, we'll just glance over it because you really don't need this now. I mean, you will eventually though. We'll look at this file again, xml.cs. Well, first I'll show you this. No, I won't show you that. I'd have to fool around to find out. Anyway, states3.xsd contains the schema definition of one of these. I forget if it's states 1 or states 2. I'll just show you how I dealt with it. So we'll go down here to where we read example 3. So, yeah, okay, we have to create a schema set, and to that schema set we have to add our schema file. And then we have to configure. So all this stuff up here is to let C# know about the schema settings. Once you've got that set up, you just read it like before. And as it's reading, it's checking to make sure that the syntax is correct. So this is exactly the same code right here as before. Now, one thing I'm doing differently is...
Because you're passing in settings into the create.
I'm trying to find out where did I pass in settings?
Create.
Oh, right here, yeah. So the XML file that you're checking has to refer to the particular XSD schema from it, and so that's what ensures that happens. But otherwise, it just automatically checks, and when there is a problem, when it detects a problem, this method is called right here. Validation callback is called, and I've written it so that it outputs validation error. So every time it sees a validation error, it'll warn us about it. So let's see how this code works. So I think it reads states3.xml. And let's I commented out this call. Okay, so now I'm going to run the code and let's see what happens. So it just read the first file for me and outputted it. It just read the second file for me and outputted it. And now it's going to read the third file. And it said the name X attribute is not declared, the required attribute name is missing. So where'd that come from? Evidently, before class I edited this file here. and, put that mistake in. So if I take that mistake out, maybe I'll put in another, I'll do that. I'll take out that. And even C# doesn't like that, but we'll go run see what it picks up. So that doesn't work, that works. Okay. So it was an unhandled exception, so I guess I could do better than that. I shouldn't let that unhandled exception propagate. I guess I think that the difference is the schema checks a valid XML file. And what I gave it wasn't a valid XML file at all. It was missing closing quote. Yeah.
How does the XML file read escape characters?
He asked about XML files and escape characters, and
Does it just take it as a string?
I don't remember exactly the escape conventions. I'd have to look it up. So anyway, just remember that all the things that you need to know about checking schemas and reading and writing XML files they're all examples here. Undo my mistake. Okay, I just have a few simple things to share with you and we'll be done. So I can remember having an internship at IBM like in 1978, I think. And they would have these sort of inspirational presentations about how well the company was doing. And they would try to measure programmer productivity, and they called it K-locks. 1,000 lines of code. So how many 1,000 lines of code does each programmer produce per year? That was sort of their measurement of everything. I didn't work there long enough to get any kind of measurement. So, but since then, people have continued to be able to measure code quality. I mean, that's essentially what we do in parts of our grading, is we try to measure code quality by having TAs look at it. It'd be nice if we could have some system, I think we eventually will, some probably based on machine learning that can grade, can do that grunt work of grading automatically. These are some things that go into code quality. So first of all, coding standards. We talked about that on the first day of class. One way companies try to ensure good code quality is to try to get programmers to adopt the same conventions when they program, so they don't have trouble reading each other's code. Many organizations have code reviews. I've thought about doing that in this class, but never have gotten around to it. Who could tell us what a code review is? Who's gone through a code review? Yeah?
It's where like each individual who's like coded a specific part of the program, they'll pop that code up on the screen and have like a group of people sit together in a room and each get their, just have the person who's reviewing it go through it, not the person who coded it, and the person who coded it tries to explain it.
So if I were to do code reviews in this class, what it would mean is I would divide you into small groups, say 4 or 5 students, and you would meet in a room and you'd show your code to each other. Each week maybe one of you would present your code and the other people would look at it and give you feedback and suggest ways to improve it. So how could doing something like that improve code quality in an organization? What would be the benefits of code reviews? Yeah?
You kind of have everyone start coding similarly, and everyone starts kind of thinking how the others
Okay, so that's one thing. It kind of enforces any coding standards you have. Would be another benefit. Yeah?
I think it helps you recognize your own mistakes and
Okay.
habits you have that might lead to that.
So you'd recognize mistake, you'd find out about mistakes you made or ways you could improve, and you'd improve that way. But what else can be a benefit? Yeah?
You can catch bugs that way.
You can catch bugs, sure. Yeah?
Gives you a negative incentive to actually do it the right way and not be lazy.
Okay, so incentivizes doing a good job. The other thing is, it's not just that you, the presenter, are going to find out what you've done wrong. The people making the suggestions may learn how to do things right. Now, Dave Johnson is experimenting with this in 1410 this semester. So he's divided the class into groups of 3. And each group meets with the TA for 10 minutes, and one of the students, for 10 minutes per week, and one of the students each week presents their solution to the previous week's assignment. So they're essentially doing code reviews. And you can imagine how that would work. If if one of your group members is strong, you're going to learn from how they did the code. And, so the improvements can flow around. Another way to measure code quality, or way to get code quality, is with compiler warnings. Set them to the highest level possible. So you can configure Visual Studio so that it will, depending on the severity of the warning, it won't show you all the warnings. Well, you want to see all the warnings. But that won't do you any good unless you do something about the warnings. I see people's code, sometimes it's just full of yellow marks because there are all these warnings that they've ignored. Usually, the warnings are there for a reason. You should heed them and try to make them go away. And here are two things you can experiment with. Code analysis tools. In fact, let's look at it. So if I go to the Analyze menu, there are a couple of ways to analyze code. So let's do that. Now, I don't have much code to analyze here. I just got this. So, where did it say to find it? Oh, that's Eclipse. I'm not going to find it. All right. So let's switch over to xml.cs, and let's go to Analyze Code Metrics for Solution. Okay, so we're going to analyze the whole thing. Actually, I'm going to do Run Code. Okay, and so I've forgotten how to get the code analysis to appear.
So does C# use like a linter? Does it like look for stylistic errors, or like does it make...
He's asking what it looks for. It'll look for all sorts of things, and you can set the configuration level, but unfortunately I've forgotten exactly how to make it appear. So I'm going to try one more time. Actually, does my slide say? Okay. Run code analysis, calculate code metrics. Well, we'll give calculate code metrics a chance. Okay, so if I dig into the XML examples, so it's rated me according to maintainability, cyclomatic complexity, depth of inheritance, class coupling, and lines of code. So maintainability, I think bigger is better. Cyclomatic complexity measures how many branches there are, so they're smaller is better. So it's just, you can look at this, and if you have like an abnormally high, a really huge cyclomatic complexity, maybe simplify your code so it doesn't use unnecessary branches, unnecessary conditionals, or unnecessary loops or whatever. And then this other thing is, I wish I could get it to come up. Run code analysis, own solution. And it's building it, but it's not showing me the...
Maybe checking the Windows tab.
Well, maybe I got to look at the source code.
There's a little box at the bottom that says code. Is that not?
That's code coverage. That's not...
Those cyclomatic values, is that based on like how it's compiled? So like if you have like an if statement and like a bunch of and ors inside of the...
Yeah, it's just how, imagine the compiled assembly code, how many branches there are.
Yeah.
So anyway, I'm sorry I didn't practice this before class, but it's worth figuring out how to do it on your own because it's amazing the kinds of error checking you can turn on. And it'll complain, for example, that your code isn't internationalized, which doesn't make any difference in this class, but if you're trying to sell an international market, then you want to do that. You want to make it so it's easy to translate the language that it uses. So try that out, and maybe you can tell me what window I need to look at. Maybe it's...
Oh, let's look at the window tab. Maybe it has it as a setting for...
Yeah, the window be called.
View.
Yeah, view is what I want to look at. Does anyone...
Is it maybe under the show output from?
Where is show output from?
So if you click out of that, it's at the top of that console, under the yellow output.
It's the drop-down menu.
Click the build.
The
Yeah.
big drop-down menu.
IntelliSense, build order. Yeah, it's not.
Test.
Oh well. I'll figure it out and I'll show you next time. All right. And then I'm going to stop there. So we'll stop there, and I'll remember how to bring up the winner next time. It's interesting to look at.